3, 2, 1.
Dr. Cooper Copper, Dr. Cooper Copper, Dr. Cooper Copper.
Electrolytic cells.
Dr. Cooper Copper, Dr. Cooper Copper, Dr. Cooper Copper.
Oxidation and reduction.
Dr. Cooper Copper, Dr. Cooper Copper.
I'll explain this so that even you can understand.
Welcome back to Chem is Fun. You're probably wondering what's an electrolytic cell. It's really simple. It's a redox reaction in which it does not happen spontaneously, and one of the substances in the reaction change its oxidation state. For the redox reaction to occur, you need an external power supply. As you can see in the diagram, the reduction occurs in the cathode, the negative charge, and the oxidation occurs in the anode, the positive charge. This occurs when there's an exchange of electrons. The negative gains electrons and the positive loses electrons.
Dr. Cooper Copper, Dr. Cooper Copper, I need your help.
Hey, person I have never met.
I need your help. In my school, my teacher told me that I have to oxidate this or she will give me an F.
Oh, that's really easy. We just have to make an electrolytic cell.
What?
Yeah, don't worry, it's really easy. We have to connect this piece of zinc with a piece of copper in a copper sulfate solution connected all together with a battery. It's really easy. Just take a look at the color of the zinc.
It's gray. It's kind of gray.
Yeah, once we oxidate it, it will change. So don't worry, you will get better than an F in your class.
Okay.
Hello class. Dr. Susie Singh will show us which materials do we need for this experiment.
This experiment is very simple. You just need copper sulfate solution, a battery, 2 Cayman cables, a piece of copper, and a piece of zinc. That is all you need for the experiment.
Thank you.
My latest, greatest work is just about completed. One more adjustment to the flux motivator.
As this is a non-spontaneous reaction, we need an external power source for the reaction to occur. Here, in the left side, we have the anode. That is the element that's going to oxidate. This one is connected to the positive side of the battery. On the right side, we have the cathode. That is the one that's going to be reduced and disconnected to the negative side of the battery.
Guys, remember, the cathode and the anode should not touch each other.
3:28 a.m. 3 weeks later, many months later.
So much later that the old narrator got tired of waiting and they had to hire a new one.
Tomorrow for sure. Eventually,
You were right. Now it's back. It oxidated. Thank you, Dr. Cooper Copper, and thank you, Dr. Susie Singh. Now I will get an A.
After building our electrolytic cell, we took both electrodes and weighted them. This will be very helpful to calculate the performance and the order of the reaction. First, to calculate the performance of the reaction, we have to know how many grams lost the zinc electrode and how many gained the copper electrode. So the percentage of performance equals the final mass of copper minus the initial mass of copper over the initial mass of zinc minus the final mass of zinc. If we substitute these values with the values in the table, we can get that the percentage of performance of the reaction was 97.3%. So if 97.3% of the mass lost by the zinc electrode was gained by the copper electrode, we can actually state that the cell we built was a very efficient one. Then, to calculate the order of the reaction, we needed to calculate the change in concentration of the copper 2+ ions in the solution. After collecting this data, we did 3 different graphs. The order 0 graph is time versus concentration. The order 1 graph is time versus natural logarithm of concentration. And the order 2 graph is time versus 1/, concentration. To know the order of the reaction, we need to find the graph with the highest R² value. In this case, is order 1. As we know, the equation for an order 1 reaction is the following. From this, we know that this little term right here equals the constant of velocity, and we can write the constant equation for the reaction like this. Where this term x right here refers to the time. After this, we can state that the law of velocity of this reaction was velocity equals the constant, that is 0.0185 times the concentration of zinc with exponent 1. Well, if you paid attention, you could learn that our reaction was a non-spontaneous one because we needed a battery for it to occur. Then, you could learn that in an electrolytic cell occurs a mass transfer, where the anode gains mass and the cathode lost mass. Also, you could learn to calculate the percentage of performance of a reaction, and also calculate the order of a reaction and the constant velocity reaction.